Today we're going to be going over the molecular mass concept. So in a previous video we've gone over atomic mass, which for example the atomic mass of hydrogen is 1.008 grams per mole, and the atomic mass of say oxygen is 16.00 grams per mole. Units are important. So what does atomic mass mean, or molar mass? All it means, these numbers mean if 1 mole of hydrogen weighs 1.008 grams and 1 mole of oxygen weighs 16.00 grams. And it's important to remember that 1 mole is equal to 6.022 times 10 to the 23rd. Technically parts, but in this case it's say atoms. So basically when you have 6.022 times 10 to the 23rd, whatever you're talking about, you can consider that as 1 mole. Okay, so now we're going to be getting to molecular mass. So atomic mass is easy. You just simply look at your periodic table and to look up the atomic mass, which will be the molar mass of that element. Let's say if you needed to know the molar mass of, let's say, water. Okay, so simply all you have to do is add up the atomic mass of every single element in there. So basically it would be the atomic mass of hydrogen times 2, because you have 2 of them, plus the atomic mass of oxygen. It's not a 0. It's oxygen. And that will equal your molecular mass. And basically the molar mass of water. So that's simply how you do it for any compound, whatever it is. But I'm not here just to show you how to do it. This is not just the molecular mass video, it's the molecular mass concept video. So I'm basically just going to explain the concept behind it, which is pretty simple, but just in case, I'm going to explain it step by step. So the molecular mass of water, this compound, is basically how much 1 mole of water weighs. And remember, 1 mole of water, so I'll use blue for water, 1 mole of water is equal to 6.022 times 10 to the 23rd, and in this case not atoms, but in this case molecules, because we're not talking about atoms anymore, we're talking about molecules. Okay, so 6.022 times 10 to the 23rd molecules. Alright, so let's see. If we have, let's say we had, okay, so in one water molecule, you're going to have 2 hydrogens, right? I mean, you can see it right there. 2 hydrogens and 1 oxygen. Okay, so 1 water molecule equals 2 hydrogens and 1 oxygen. But let's say we had 1 mole of water molecules. So we have 1 mole of water molecules. That means we have 6.022 times 10 to the 23rd H2Os. Right? So that is 1 mole. So what does that mean for this? That means you're going to have 6.022 times 10 to the 23rd atoms of hydrogen, and don't forget times 2, because you got 2 in water, times 2, plus 6.022 times 10 to the 23rd atoms of oxygen. Once again, that O is not a 0. That's an O for oxygen. Okay, so let's recap real quick. In one water molecule, we have 2 hydrogen atoms. and 1 oxygen atom. That's oxygen. So if we have 1 mole of water molecules, that means we have 6.022 times 10 to the 23rd molecules. So we don't have 1 anymore, we have this many, 6.022 times 10 to the 23rd. So we just multiplied it by 6.022 times 10 to the 23rd. So instead of 2 hydrogen atoms, we're going to have 6.022 times 10 to the 23rd times 2. And then instead of 1 oxygen atom, we're going to have 6.022 times 10 to the 23rd. And I know I'm saying 6.022 times 10 to the 23rd a lot, but it's going to be used a lot in chemistry, so hopefully just by you listening to this video, you'll kind of memorize this number. So, now we can sort of break this down now. Let's see. Now, 6.022 times 10 to the 23rd atoms of hydrogen. We know what that is. We know exactly what that is, because if we look at the periodic table, the atomic mass is 1.008. And this right here, this is how much 1 mole of hydrogen weighs, which means this is how much 6.022 times 10 to the 23rd atoms of hydrogen weigh. So instead of writing that number, we can just write 2 times 1.008. Yeah? See how we did that? If you didn't, it'll make sense when we do it for this one. So 6.022 times 10 to the 23rd oxygen atoms. Now instead of writing that whole thing out and trying to weigh that, we can just look at the periodic table, look up oxygen, and we'll find this number, 16.00. 16.00 grams is how much 1 mole of oxygen weighs. So therefore, 16 grams is equal to how much 6.022 times 10 to the 23rd atoms of oxygen weighs. So this right here, this quantity right here, is equal to 16. Yeah? You see how I'm doing that? And then, let's look at this. 6.022 times 10 to the 23rd molecules of water. Now we already said that the definition of 6.022 times 10 to the 23rd is 1 mole. So therefore we can just change that to 1 mole of H2O. Then if we just do this math, 2 times 1.008 plus 16, that equals about 18.02 after rounding. So this number right here that we just found, changing my color, this number right here, this is equal to 1 mole of water. And of course, these numbers that we looked up in the periodic table are in grams, so therefore this will be in grams. Okay, so this is the molecular mass of water, and we found it simply, I broke it down for you, but all we did is we took the atomic mass of hydrogen, which it consists of, and multiplied it times 2, because there's 2 of them, and then we added it to the atomic mass of oxygen, which we find in the periodic table. So basically, you just look at what the molecule consists of, and you add up all the atomic masses. If there's 2 of them, you multiply it times 2. If there's 3, you multiply it times 3, and so on. Add all those numbers up, and that will give you the molar mass of the water molecule. Now, to get the units correct, there are 18.02 grams. Well, let's write it like this. 1 mole of H2O is equal to 18.02 grams, right? So you can kind of convert that to a conversion factor with the correct units to that, just like this. 18.02 grams per 1 mole of water. So this right here is the molar mass of water. Now I know this is a 10-minute long video. I didn't mean to overcomplicate things. Like I said, all you had to do is add up the atomic mass of all the elements that the compound consists of, and that'll give you the molecular mass. All this right here is just breaking it down, showing the concept and intuition behind it. So while you're doing all this, you'll understand why you're just adding up the atomic masses.